I'm going to go over this extra example with you. Find the area in the figure enclosed by the graph of square root x, x plus y equals 6 in the x-axis. So square root x is the red graph, x plus y equals 6 is the blue one, and the region is what's trapped in between those two and the x-axis. So there is actually a multitude of ways. I've seen at least 5 or 6 different ways to get the area of this region. The first thing we can do to get the area is figure out where square root x equals negative x plus 6. If I solve this equation for y, you get negative x plus 6. So if you set those equal, you would get x equals 4. So the area is going to be the integral from 0 to 4 of the square root graph plus the integral from 4 to 6 of negative x plus 6. Okay, so we're essentially splitting it up into two regions, where this is region 1 and this is region 2. And then, so you would have A1 plus A2. And if you took the antiderivatives, plugged in the upper and lower, you would get 22 over 3. Okay, but there are other ways to do this. I want to show you a couple more. Okay, another way to think about this is using geometry a little bit. So we still have those two separate regions. This first region, we'll call that A1. A1 is equal to the integral from 0 to 4 of square root x dx. Plus, this last piece here is just a triangle. So without even using calculus, we could do 1/2 base, which is 2 units, times height, which is 2 units. And again, you would get 22/3. However, there are still more ways to do this one. Let me show you a couple more. Another way to think about this one is to consider making a horizontal strip like this. And then your integral is going to be from 0 to 2, because now you have to integrate with respect to y, of the line, which is x equals negative y plus 6. Okay, so negative y plus 6 minus, so that's right minus left. Now the left is going to be the sideways, or the square root graph, but if y equals square root x, I need to solve that for x, and x equals y squared, so minus y squared. Integrate with respect to y. And again, in this one, you're still going to get 22/3 as the answer. Still, yet another way to get the area is to think of the line as making a giant triangle. So the area would be 1/2 6 times 6. All right, that would give you all of this, right? But what we don't want is this almost kind of shark fin looking region right there. So we would have to subtract that off, and to get that area, it would be the integral from 0 to 2. Now, in this case, the top is negative x plus 6 minus square root x, because you would have to go top minus bottom here between those two, and then we would subtract that off. We'd figure that area out with a definite integral and subtract that off. Yet another way that we could do this is start off with the integral from 0 to 6 of the square root of x dx. What that actually is going to do is give us all the area from 0 to 6. Now you can see again, we got too much because we don't want that part I just shaded in blue, which is actually a region bounded by the square root in the line. So we could subtract off the integral from 4 to 6 of square root x minus, so top minus bottom would be negative x plus 6 dx. I'm just showing you a bunch of ways to set these up here, and not actually going through all the steps of figuring out the final answer from there. But I just thought that was pretty cool because there's so many ways to figure this out. I know there's more. This isn't all of them, but sometimes you have to think outside of the box a little bit to figure out the area of the region. And sometimes different methods are going to be a whole lot easier than other methods. All right, guys, that's it for this one. Hope that helped. Take care.